All right, we're going to do some practice problems here on SN1, SN2, E1, E2. I thought we could walk through the strategy together for a handful of problems. There's a blank copy of this on eCampus with the link to the video, as well as the charts. So during this, we are going to be identifying info about the substrate, about the reagent. If there is a solvent, we'll be analyzing the solvent. We'll come up with the mechanism, and we will predict a product, thinking about regio and stereochemistry if appropriate. So on this first example, right, we have a tertiary alkyl halide, and we have a weak base, weak nucleophile, right? We have water. Weak base, weak nucleophile with any kind of alkyl halide is going to give a combination of SN1 and E1. For the SN1 product, we are going to be replacing the chlorine with an OH. Right? For our weak base and weak nucleophile, you do lose a proton at the very end to make a neutral product. It's not a chiral center. We don't know any stereochemistry, but SN1 would give a mixture anyway. It is important to note that for E1, if you have a choice, and here we do have a choice, there are different beta hydrogens that would lead to more or less substituted product. E1 is going to give you the Zaitsev product. So we are going to get the more stable, more substituted double bond. I could have drawn it to the right or the left, as long as it's in the more substituted position. Winds up being the same product. For the next problem, we have the same starting material, a tertiary alkyl halide, and we have a strong nucleophile, but a bromide is a weak base. Now, when we have a strong nucleophile, but it's a weak base, it's going to want to do substitution. And since it's strong, it would prefer SN2, but we'll take SN1 if we have to, which we have to because we have a tertiary alkyl halide. Tertiary alkyl halides cannot have an SN2 reaction. So we will have SN1. So again, we'd get a mixture of stereochemistry, not that it matters here because it's not a chiral center. For the next reaction, we have a secondary alkyl halide. We have a strong base, strong nucleophile. Strong bases and strong nucleophiles can have an SN2 or E2 reaction. Secondary alkyl halides could participate in both, so our solvent is going to help us out here. An SN2 reaction is sped up by using an aprotic solvent. So aprotic solvents will tend to favor SN2, DMF being one of those aprotic solvents. Now, an SN2 reaction should give us inversion of stereochemistry. So when I go to draw my product, nothing happens to the ring. This OH is going to attack from the back as the bromine leaves off the front. So we're going to use a dashed bond to show that new alcohol. About halfway done here. Now we've got a primary alkyl halide. We have a strong base, strong nucleophile. Could be SN2, could be E2. There's no solvent. Maybe I didn't put a solvent because you don't actually need the solvent on this one. E2 is not possible because there is no beta hydrogen. We cannot put a double bond back this way because that would put 5 bonds on this little carbon, and we can't do that. So E2 isn't possible no matter what solvent you use here. So we must go with SN2. Since it's primary, it's not a chiral center, so we don't have a wedge or a dash. We don't have to we don't have to consider the wedge or the dash in our product. NaOCH3 is going to put the OCH3 in place of the bromine. Second to last problem, we have a tertiary alkyl halide, and we've got a bulky base, right? So what does a bulky base tell us? They are strong bases, but they are not very good nucleophiles. This is going to most likely go through E2. T-butanol is just a protic solvent. We don't necessarily need to know that here. Now, if we're going to eliminate, we have two different options, right? We can take an H from the methyl group or an H from the ring. E2 mechanisms with a bulky base are going to prefer Hofmann, right? So instead of the Zaitsev product, we are going to go for the less substituted double bond. That big bulky T-butyl group has a hard time getting in closer to the ring. And so that is why we would predict this particular Hofmann product. And in our final example, we have another elimination I want us to look at. We have a secondary alkyl halide. We have a strong nucleophile, strong base with the NaOH. We have a protic solvent. So that is going to speed up the E2 reaction. But remember, E2 is anti-periplanar. So it actually does matter in this particular ring where the hydrogens are. Now, often with a hydroxide E2, we would get Zaitsev. But it needs to be anti. To be anti-periplanar on a ring, your hydrogen needs to be on the same side of, on the opposite side of the ring. So the Zaitsev, or more substituted double bond, the hydrogen's not in the right place. This hydrogen over here, I guess it doesn't really matter. They're both they're both substituted. But anyway, this one is gonna the anti-periplanar will help you decide which direction to go. You're gonna have an H on this side that's on opposite side of the ring. So this one can be anti to the bromine and be in the same plane. So we're gonna pluck off that hydrogen, make our double bond, kick out our bromine. So we're gonna wind up with the double bond going to the left rather than to the right. We didn't do anything on that ethyl group, so we leave that stereochemistry alone. All right, so at the very end, we did have to pay attention to that anti-periplanar, but you only really have to think about this when it is an E2 reaction and you have some stereochemistry to work with. I hope this helps. You should be able to find lots of extra practice in your old tests, old homework, and shoot me an email or a group me if you have any questions. Thank you.